So, tutorial number 3. This one is going to be all about the software. We yesterday had this little program which we'll run to the bot just to always comes up with board updates. Run to the bot just so we can verify that it's still working. 5-second delay. I'm going to shorten that right down next. And as we've touched the whiskers, the robot things, which a robot that runs into a wall and stops might be amusing in some respects, but it doesn't really achieve a great deal. So first thing I'm going to do is take that down to 2 seconds, partly because it'll shorten this whole tutorial. Then I'm going to add an integer, my time base, only so that I can set that to 250 equals 250, only so that we now have a nice little box with a 250 which is in milliseconds going to be a quarter of a second. And if we want to alter all the time bases, slow the robot down, change things, then we can do it just by altering one variable. Right, so then I'm going to go down and collect those two there and delete them there, and go down to the bottom and get rid of that space there, go past that bottom loop, and then so we're now outside the void loop and create a new void. So what this is, my forward, this is now, I don't know, I keep it in the backspace instead of the return today. So it's automatically put, as soon as I press return, let's put the second bracket in. So I'm now inside this little extra void created that put those two commands. Now then, for good practice, I'm also going to put in the command for the other pins. And the reason I'm doing this is as you get deeper in and messing about with switching things off, if you don't make sure that all your pins are set properly, then you can end up with a situation that the robot's not making sense, and it's because you've got two pins on either side of the motor set high, and the L298 automatically assumes that if you had right forward and right backwards high, that means nothing, and so instead of trying to send power to both sides of the motor and shorten your battery out and blowing the 298 out, it ignores just a little logic chip that says you can't do that. So that void there now is literally can be called just by saying my forward. So we've not really achieved anything, but what we've done is we've created an object called my forward. So if I load that down to the robot, compile it and then upload it, it doesn't really make a lot of difference to what it's doing. It's still bump and stop bot, but what we're doing now is we're starting to sow the seeds for making a much more programmable system. So I'm going to also copy that command there and delete it. Come down here and create a void my backwards. So what it's done, and I need to put a space there, otherwise it can't see it. We'll drop the two commands in there, and then, as I say, we will also go in and make sure that the other two are set. So although we've already, in some respects, it doesn't look like what we're doing is adding a great deal. What we are doing is guaranteeing that all the pins are set the way we expect them. Now then, my backwards, sorry, isn't right. That's not right. That's not right. That's not right. That is my stop. Because it wouldn't go backwards because they'd all switched off. I now copy that and say I actually want to command my backwards, then what I need then is I need those two high. Like I say, one of the things you get over time is you can look at the commands and you can visualize the pins. So we've got three objects there. So if I now go back in there and put in that as stop, or stop, then we're actually in a situation where we've achieved nothing, but we have achieved the objects. And I'll show you where this really starts making sense. So if we now go, we'll load that in, and we'll go back to the bot. It is sometimes worth going back just to prove that what you've done does work. Occasionally you think what you've done makes sense, and it's absolute nonsense. So the robot is still bump and stop robot. So where we're going to take this from here now is I'm going to pick up my forwards, copy that whole thing, and add the command in, or add the void, my left, back. So what it will do here is right forward is going to be low, so is left forward, and left backwards is going to be high. Right, so we'll not do a lot more just yet. We'll actually see what we're going to do with that. So we now know that that robot stops. Thing is, it's just all it's doing is I'm doing it again. All it does is stop. So what I'm going to do is inside here now I'm going to add, or I'm going to cheat initially by copying that first part of the if statement. I'll stick that in there. Add the bracket, and then add two curly brackets. So what we've got now is an if statement inside an if statement. We call this nesting. So what you've got there is if that, then it stops. But now we're saying if, we're also saying, but in that stop condition, if the left is the one that was switched, then what we're going to do is we're going to go my backwards, and then we're going to delay and leave that command switched on for my time base. Then we're going to go my left back, and again we're going to delay for my time base. So in a way that is very easy to read, we can now see that what we're doing is we're saying my backwards, my left, so that initially when if that switch is pulled, it's going to pull over, you're going to back away. It's then going to pull backwards left, and then we'll see what happens there. It's actually going to go wrong. I'm going to give you that heads up. It's going to go wrong, but it'll be interesting to see why it does go wrong. So we'll now go back over to the vehicle, the ribbot, tablebot, whatever you want to call it. Uploading. 2-second delay. So we're going forwards. and for a split second it goes into reverse and then stops. So we're now in a situation where the logics are locking each other out. Right, so what I'm going to do now is go back in and see if any of those, so what we've said is if any of those switches are pressed, then stop. But then we're saying if it's the left switch, then go backwards to start with for a quarter of a second, then go left. So what we're trying to do is turn away from that switch. But as you've seen, it then means that we need to switch the motors back on. So if I say my forward down there and program that, now it's difficult to see that the actual left motor is doing a bit more turning, but we've now got a robot that reverses away, but it's only doing it on the one switch. Right, so what we're going to have to do is go back into the software, and we're going to, because we've got a situation now where we've got a solution for if it hits the left button, but we haven't got one if it hits the right button. So again, inside that loop, we're going to now copy that whole statement. So if it's the right button, this time, call up right back. Now we know we haven't got a right back, so we're going to copy that there and recall that right back, and then we spot that actually the reason it didn't look like there was a lot happening was because we hadn't actually set it. There you see. So what I'm going to do now is go back into that and set that high, and then down here set that high, which that's the problem with quarter of a second. You know, initially we would have wondered why the robot wasn't turning. But you've got to spot these things as you go. Right, so we'll program that. Go over to the robot. So now we've got a situation where, yes, you can tell it goes a bit further. Yeah, and yeah. So we've now got a situation where those two are touched. So the last thing we need to do now is fairly quickly go in and, copy right switch and turn that into middle switch. So that we've now got a third switch. So what I'm going to do is I'm actually having it go backwards, but I'm actually going to have it go backwards twice the time base. So if you go start 2, if X being a letter, when they're doing multiplication in robots or in this language, you use a star to say times. Now then I might leave the right in, because what I don't want it to do is just keep bumping up against a square wall. I actually do want it to turn, but I'm going to get it come back a bit further before it turns. So we'll load that in. Over to the bot. So we've now got an if statement that works on all 3 of the switches. So I'm not really going to do a lot more with this tutorial, because you've got enough there to create a basic robot that will avoid the walls, or it won't avoid them, it'll actually react to the walls. I'm going to go over to the arena now and let's actually see this little robot in action and see how he actually performs. If I could turn the switch on. Still a bit bumpy, still a bit vicious, and I get the feeling that one motor's running slightly faster than the other. I think we might have to look at slowing him down in the next thing, which will be useful because we'll look at pulse width modulation.